It's good to teach science as a story, as a history, as something that develops as scientists improve things over time. So, for instance, DNA and inheritance, I would ask the students, what did people believe before we discovered DNA? And then people would be a little confused, and I would say, before we knew what was inside your cells, the DNA that's always mentioned on television, the chemical that's at the center of every cell, apart from your red blood cells, every alive cell, that is. How did they think that people with black hair got mostly babies with black hair? How did they think this inheritance happened? Who were the main movers that we've got to know about for your GCSE? What did they think? And so, because it's an easy option, someone's bound to say, oh, God did it. And then you say, yes, and some people still believe that, and that's great, that's fine. That's not what this GCSE is about. The study of that is called theology. So, yeah, there's the God thing, and that's okay. But what about the other scientists? The theories? Darwin might have to be put into that gap. So I'll put a line on the board and say, who was the guy that invented this science? No one puts their hands up? I'll get them to write in their books. Was the guy that invented this science of evolution that then became DNA inheritance? Anyone know his name? D-A-R? Hopefully we'll get somebody that says Darwin, but it doesn't matter. It's making it interesting. It's making a game out of it. It's trying to draw it. And then someone's going to go, I know that. And that makes it funny. And then I'll tell them that before Darwin came along, the scientists, the ones that weren't so God-oriented, they thought that barnacle geese, it's a bird, came from barnacles. Hence they're called barnacle geese. The geese went away. They disappeared for months. And they always reappeared just after there was a whole bunch of little sea creatures called barnacles stuck to ships on the rocks. And so people went, oh, I've got a theory. I reckon the geese hatch out of the barnacles, just like chickens hatch out of eggs. And that was very silly, and now it's wrong, and now it's funny, and yeah. So, biology progresses. We don't know what we're going to discover next, and that's why we learn science or biology. For chemistry, the big one were the elements. At first, there were 4 elements. Who can name the elements? The 4 elements. Put them on the board. That word, put it on the board. Yeah, people thought that when you mix up some fire, some earth, which means ground, soil, some water, and some air, you got different things. You got fish. If you had a bit of this, and a large bit of that, lots of water. They thought you got humans by having all 4 of them, but mostly water. It's 70%. Well, between 65 and 70, depending on how healthy you are, how much you've been drinking. The colour of your urine is very important. They thought that these elements put together made everything else on Earth. And kind of they were right. Because we now know that the elements put together, not just mixed, but heated up, bonded, chemically reacted together, do make humans. But there are more than 4. Then there became a 5th one, and I'm going to have to Google that. The 5th one was soul? There was a 5th one. And then people found other things, like they found silver and gold. they were elements because you couldn't split them apart to make any soil and fire out of them, which people thought soil and fire made gold. They thought it was different combinations of these 4, then 5 elements. And we now know there is a lot more. There's gold and silver. Can anyone else name any other elements? And then you'll get lots of things that aren't elements, water. No, water's actually H2O. We now know it's hydrogen and oxygen. Hydro means water. Hydrogen comes from water. Oxygen, oh, actually that was a wrong theory. We've still got the name for it. It's about burning. So we've got wrong theories in the past, and they got better and better. We now know there are 92 elements. You need about 60 to make a human. They're bonded together, not just mixed up. Actually chemically joined together elements. Mostly oxygen, hydrogen, carbon. Just like trees and plastic. You're mostly those things. But also lots of other bits. There's tiny amounts of gold that have to be in you in order to keep you alive and healthy. And iodine and all sorts of other silver. They all, many of them, have to be in there. And so I like my students to see how science progresses. Wrong science become right science. And physics, the easy one, that's a good, nice story, of course, is what did people used to think the shape of the earth was? And someone's going to say it's flat. And then you see, very few people, only people that never saw the sea thought this. Nowadays, there's actually more people that think this than there was 1,000, 2,000 years ago. Because people went to the sea a lot, and because they noticed that when ships go over the edge of the horizon, the sail is the last bit you see, and the first bit you see when they come back. It can't be flat, otherwise it would just get smaller and smaller and smaller and smaller and smaller, and it wouldn't go over the sphere of the earth, because it's a bullshit sphere, not a circle. Because flat circles, Terry Pratchett did a whole bunch of books about that, brilliant. But then what did they believe? When they got to, they got almost everybody, more people than now, believing that the earth was a sphere. Then what did they believe about the sun? How does the sun move? And then people go, the sun goes across the sky. Yeah, it rises in the east, sets in the west. People thought it was a ball of fire, maybe bigger than this skull. Was that true? And then people would go, no, I think it's much, much bigger than that. Who's bigger than the earth? Who thinks it's bigger than the earth? Hands up. Yes, well done those people. It's bigger than the earth. Thousands of times bigger than the earth. It took us a long time to work that out. By looking at the shadows of the earth on the moon, we worked that out. Thousands of times bigger than the earth. So is it the little thing and the big thing goes around? Or is it the big thing in the middle and the little thing goes around? Which one makes more sense? Hands up. Who thinks the earth goes around the sun? Who thinks the sun goes around the earth? Yes, I can understand why you'd think the sun goes around the earth, because it looks like we're stationary and the sun... But no, it's because we're spinning. Because if that's you, here, I'll draw you on my hand. My face is the sun, and this is the earth. Every day the earth moves round, which makes it look like, from your point of view, that the sun is going across. But no, it's actually the earth every day turns round. It takes a whole year for it to go round the sun. It's a long distance. Long distance, many thousands of miles. So what did they discover next? Oh, what about the moon? Is it that the small one goes around the big one, or the big one goes around the small one? No, it's always the small one goes around the big one. Well, actually, they both go around one point that's slightly, a little bit, is mostly the small one goes around the big one. That's all you need for GCSEs. Slightly more complicated, and you learn that as you become an astronomer, because there are people still out there studying this stuff. This is the enthusiasm. This is why I'm teaching you physics and astronomy and equations and mathematics. So you can learn about the next thing. So, what is the sun going round? And then someone might say black hole, and I'll say, yes, the sun and all the other suns that we can easily see in the sky, they're all going round a big black hole. Big, very massive, well, actually tiny, but it's because all the mass is squashed into one small place. But really massive, got the mass of thousands of our sun, all squashed in one small, very small place. So what's the movement of our galaxy? The black hole. All these stars spinning around the black hole. Thousands and thousands, millions of stars going around the Milky Way. If you go to Australia, look in the sky, middle of the desert, you'll see millions of stars lighting up the sky, and it looks like milk has been splashed across the sky. That's why it's called the Milky Way. You can't see it anywhere around here because people have got their lights on at night, and so it needs to be very, very dark. It means to be right in the middle of a desert so they can see. Yeah. So how's they found out recently about the movement of all of these millions of galaxies? What are they doing? They're not spinning. No, they're actually Big Bang. They're going away. There was a bang, it was a big one, and it exploded all the galaxies. And the galaxies' dust became all the stars, the spinny, black hole in the middle. Everything came from this Big Bang, and much to everyone's confusion, we still haven't worked it out. You can become famous if you figure out why it's accelerating, and that's called dark energy. And we don't know what it is. Someone's going to become famous by figuring out, by using maths to work out the equations for dark energy. The reason why the banginess of the Big Bang is speeding up. Pretty cool.